effects of parameter k on y equals cos kx. We shall now investigate the effect of k on the function y equals cos kx. Consider the cosine function y equals a cos k theta plus q, where a equals 1, q equals 0, and k equals 1. It becomes the cosine function y equals cos theta, which we saw earlier. Consider the cosine function where k equals 2. The function becomes y equals cos 2 theta. We can calculate the y values of this function and plot the graph on the same set of axes. Observe that the amplitude of the graph of y equals cos 2 theta is the same as that of the graph of y equals cos theta. Hence the amplitude of the graph has not changed. However, the period of the function has changed. Period of the function y equals cos 2 theta is 180 degrees, which is half of the period of the function y equals cos theta. Hence we can say that changing the parameter k affects the period of the function. Now let us consider an example when k is less than 1, say 1 over 2. The function becomes y equals cos theta over 2. We can calculate the y values and plot the graph on the same set of axes. Again, there is no change in the amplitude. However, the period of the function has changed. Observe that the period of the function y equals cos theta over 2 has in fact doubled when compared to the period of the function y equals cos theta. Now let us consider a couple of examples where k is less than 0. Again, amplitude does not change. However, when k is negative 2, the period has reduced by half. Let us summarize our findings on the effect of parameter k on the cosine function. For k greater than 1, the period of the cosine function decreases. For k greater than 0, but less than 1, the period of the cosine function increases. For k greater than negative 1, but less than 0, the graph is reflected about the y-axis, and the period of the function increases. For k less than negative 1, the graph is reflected about the y-axis, and the period of the function decreases. Note that we can also calculate the period of the function algebraically. We simply divide the period of the basic cosine function by the magnitude of k, that is, ignoring the sign.
Need more help? Subscribe to our channel. Can't wait that long? Ask Maskly to help you and let the math finally start mathing.